Let's play with antiderivatives some more. Let's say if f of x equals x squared plus 7, actually here we're taking derivatives. What is f prime? You'd say 2x, right? If f of x was x squared plus 13, you'd say f prime is 2x. What if f of x equals x squared minus a million? What is f prime? Take the derivative, the million becomes 0 because that's just a constant shift. So you'd still get 2x. So then, if I said if g prime of x equals 2x, what is g of x? Well, before, when I was kind of feeding us answers right before we did things backwards, we would have said, well, wherever this is, 2x, just go backwards. But now it seems like there's 3 different options, and probably more, right? So we could say it's not just x squared plus some constant, but we have no idea, no way of knowing what without some further information. So it's x squared plus some constant. So another way of saying what's going on here is that a constant vertical shift in f doesn't affect or show up in f prime, right? So vertical shift in f doesn't affect the slope . So once you take a derivative, it's kind of like that vertical shift information is lost forever. So to write this slightly more formally, we say if here, actually let's call it g of x for this example would be x squared plus some constant we don't know, but we have to have a more formal name than that. And so instead of writing out some constant we don't know each time, we're going to say c, and that's a capital C. And this could be positive, could be negative, could be 0. I want to highlight that this is a capital C, the uppercase C, not a lowercase c. So to summarize here, capital C is a vertical shift. It's kind of like a y value. It has the same units as y, but it's not necessarily the vertical, the y-intercept. It's not always the y-intercept. Little c, can you tell the difference in the size there, is a position on the horizontal axis. Same units as x. And you probably remember the famous formula f of c plus f prime of c times x minus c. There, if c wasn't in the same units as x, you wouldn't be able to subtract it. So we have separate notation for, sometimes we want to have this vertical shift we can kind of adjust, sometimes we don't. So sometimes we want the general antiderivative, an antiderivative that represents the all possible antiderivative formulas. So sometimes we want the general antiderivative like x squared plus c. But sometimes we don't want that kind of ambiguity. We want a specific antiderivative that works in specific examples, or maybe the plus c ends up just not mattering. So sometimes we want it's called the particular antiderivative. Like x squared or x squared plus 13 or something. All right, so in our textbook, one way they make the distinction between when we want this, when we want that, if it says an antiderivative, it means a particular. So you don't need the plus c. And if it says the antiderivative, that means the general. So you need the plus c. So there's new notation here. If we say the antiderivative of f is written this way, this big new sign that's called an integral sign, f of x dx, and we'll explain more what the dx means later. It is related to the differentials we talked about in chapter 4.4, and it is really a multiply. We're really multiplying f of x times dx, so the units all have to work out and everything, but we'll talk more about it later. This thing right here is an integral sign. Sign not like positive or negative, but sign like stop sign, yield sign. It's something that says, hey, take the antiderivative. And it's an elongated s. Because it's related to summing. All right, and the variable after the d, like dx or dt, tells us has to match the variable that we're giving the function. So the variable shown in the differential matches whatever variable in our expression of f that we have. So you can see integral of f of x dx, but you could also do integral f of t dt. You could do integral of q of s ds. You can use any name there, right? I think emojis don't get enough use in math, so you could say integral of a of smiley face, and then here you'd have to say d smiley face. Why not?